Okay, come, let's do the probability. Leave it. Shouldn't eat sweet. Okay, so the question starts. An unbiased six-sided die is thrown twice. Okay, thrown twice. So find the probability that the total score is 8. Take note, total score means you're supposed to add the score. So actually, this kind of question, you can actually draw a possibility diagram as well. It looks something like that. But this table behind is for multiplication. But we can do the same for addition. Okay? So you see, I have my first throw, I have the possibility of 1, 2, 3, 4, 5, 6 because it's a 6-face die. Then, because you're going to throw 2 times, so we put another time, will be 1, 2, 3, 4, 5, 6 as well. Okay, this one will be used for the multiplication. So we're going to draw the same kind of a table, but for addition. Because this is the total score. So I'm going to draw here. Okay. So it will be this is the addition one. So I have 1, 2, 3, 4, 5, and 6. Okay. 1, 2, 3, 4, 5, and 6. Okay. So with this, you'll be able to see what is the total score of the two throw. Unbiased is because it means that every phase is equal probability. Okay. If you see biased dice, it means that, let's say for example, maybe a die is biased to throw at 1. So throwing 1 has a higher probability than the other 5 phase. Okay, that's called a biased dice. But unbiased means all 6 phase has equal probability. Okay. So this is how it works. You fill up the table. So it's like if I first throw is 1, second throw is also 1. Add up together, the score is 2. So it's a 1 plus 2. So it will be 3, 4, 5, 6, 7. This will be 3, 4, 5, 6, 7, and 8. 1 plus 3, 4, 5, 6, 7, 8, and 9. 1 plus 4, 5, 6, 7, 8, 9, and 10. 1 plus 5, 6, 7, 8, 9, 10, and 11. 1 plus 6, 7, 8, 9, 10, 11, and 12. So with this, you can see all the possibility of the total score. So they ask, find the probability that the total score is 8. So how many probability total do I have? Okay, so probability of total score equals to 8 is equals to, the total probability that I have is 6 by 6. So it's 6 times 6, which is 36. So it's out of 36. So let's go and see how many 8 we have. Okay, so we have 1, 2, 3, 4, 5. So we have 5 possibility whereby the total score is 8. So you will put 5 at the top. Okay, so it's just 5 out of 36. That's all. Okay, and next is, what's the probability that both scores are different? Okay, both scores are different. So you see, this one means that 1, 1 is not included, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6 is not included. Correct? Because they want it to be different score. That means you throw the face is different. So that means, in other words, this, it is referring to the same score. So same score, I have 6, right? So just now total I have 36. So for probability of both scores different, it will be 36 minus 6, which is 30. So 30 out of total, which is 36. And of course, we can reduce this to the lowest term. So it is 5 over 6. Okay. So it's just like that. Okay, so let's move on. Next, now they say, okay, the two scores are now multiplied together. Just now that one is add together. Complete the table below to show all the possible outcomes. So it's like 1 times 1, you get 1, 1 times 2, 2, 1 times 3, 3, and blah, blah, blah. So let's fill it up. So 2 times 3, we get 6. So 2 times 4, we get 8. So 2 times 5, we get 10, and this is 12. 3 times 1, we get 3. This one already filled up. Next, 4 times 1, 4. 5 times 1, 5, and 6. This is 3 times 4, so it's 12. 5 times 4, so this is 20. 6 times 4, so it's 24. 3 times 5, which is 15. 5, this one filled up already. Okay, now here. 3 times 6, which is 18. 5 times 6, which is 30. 6 times 6, which is 36. So we have all the scores for multiplying together. So now then, look at the question. They say, hence, find the probability that the product is an odd number. Okay, so you will say probability product is odd. Okay, again, you have how many? 6 by 6. So it's out of 36. So now you have to go and count how many numbers is odd. Right? 1, 2, 3. This one definitely don't have because the second row is all even. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's only 9 out of 36. 9 out of 36 is odd. Okay, and we reduce the lowest term, so it's 1/4. Done. Okay, next, they say the product is at least 20. At least 20 means 20 and above. This means is 20 and above. So by looking at the table again, okay, so probability of at least 20 is equals to, so let's take a look at the table and count how many. We have 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 out of 36. Reduce it to the lowest term. So divided by 4 is 2, divided by 4 is 9. So it's 2 out of 9. Okay? So this is easy. All you need to do is you got to list down the outcome, all the possible outcomes. So a possibility table is very helpful for you to list down all the outcomes. It's very clear. Okay? Next, we're going to do a tree diagram. Okay? Okay, let's read the question. So Ben has 12 sweets. So 5 are orange, 6 are purple, and 1 is red. He takes 2 sweets at random from the can, one after another. So you're going to pick 2 sweets out of the 12 sweets. So maybe at the side here, I will put 12 sweets. I have 3 possibilities. I have 5 orange, I have 6 purple, and I have 1 red. Okay, putting these at one side, this side is easier for you to see comparing to looking at this side. So let's see. I'm going to pick the first sweet. So you can see this one is first sweet. To pick an orange, because I have total 12 orange. Total 12. So, and I have 5 orange. So that's why it's 5 out of 12. Okay, look at this purple. Purple, I have 6. So it's 6 out of 12. Okay, student asked me, do I have to reduce this? Yes, we have to reduce. But please keep the 6 out of 12 here. So this is half. Why is it I want to keep the 6 out of 12 here? So you know that when you come to here, you know that, oh, 1 is taken up. I left with 11 at the total. Okay, if you put half only, you won't be able to see clearly what is the original total. You understand? So you can put 6 out of 12, then just put equals to half. Okay, for the red, I have only 1 red. So it's 1 out of 12. Okay, 1 out of 12. So now, the first sweet for orange, purple, and red, the probability is over here already. Now, let's move on. So this is how it works. You pick the first sweet is orange. Then now you're going to pick the second sweet. You see the total? Because the 12, I already take out one orange. So my total sweet now only left with 11. So the total, you can see that it becomes 11. For the orange, why is it 4? Because I already took out the first orange. So I only left with 4 orange inside for me to choose. That's why it's 4 out of 11. Okay, how about the purple? Okay, this means that I'm going to pick the first sweet is orange, second sweet is purple. Okay, the total is still 11 because I already took out the first sweet. Okay, the purple over here, 6 purple, because when I pick the orange, I still have 6 purple inside the bag. So over here is still 6 out of 11. Red, same thing, the total still 11 because minus the first sweet. And then after that, the red, I have only 1. So the possibility is only 1 out of 11. Okay, so let's move on to the next. So now, my first sweet I take out is purple. Now the second sweet is orange. Again, my total now is 11 because I already take out one purple. So only left with 11 sweets inside the bag. As for the orange, because the first sweet was purple, okay, so my orange was not touched. So I still have 5 orange for me to pick. So this is 5 out of 11. Okay, so this is 5 out of 11. Okay, so now next, purple. My first purple is already taken. So if I take out first purple, that means actually I only left with 5 purple. So this is 5 out of 11. Okay, so the red is already filled up for you. Okay, next. Over here, my red. My first sweet is red. I took out 1. I'm going to pick orange. Again, my orange is not touched. So it's 5 out of 11. Purple also was not touched. That's why it's 6 out of 11. How about the red? Because my red only have 1 red. If the first sweet is already taken out, that means I don't have any red in my bag anymore. So in this case, it's not possible to get a second red. So it is a 0. Okay? So far, okay? You all must know how to fill up this tree diagram. Tree diagram. Okay? So after filling up this one, what I want you to do is, at the side here, you can write out, this is OO, right? So you will write that this is orange, orange. Okay? Why is it that I want you to write this? Later when we answer the question, you will understand why it's easier to write. It will be easier to refer when you write this. This is OP. So this is orange, purple. This is orange, red. This is purple, orange, purple, orange, purple, 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 red. Red and orange. Red and purple. Red, red. Okay? So by listing this at the side, it's easier for you to see later. So let's answer some of the questions. Hi, Cher. Sorry I haven't been coming to live because I have a lot of homework. How was your statistic mini test? Minecraft? Okay. You can come and attend. Never mind, you can plan your time. You can always go back to the YouTube channel and watch the replay lah. Okay, so now we're going to answer the question over here. Wow, Minecraft, congrats. Okay, so find the probability that both sweets are orange. You see, with this, right, it's easier to see. Both sweets are orange. It's only this part. Okay, so you can see that writing this down helps you a lot. So I know it's this. So in order to get orange, orange, I know that I have to go through this branch and this branch. Okay, so when it happens together, it is multiply. Okay, so my B part 1, I will write probability of both orange will be 5 out of 12 multiplied by 4 out of 11. Okay, and of course leave it to the calculator. So I'm going to press calculator. Fraction 5 out of 12 multiplied by 4 out of 11. And that will give us 5 out of 33. Done. Okay. Okay, now let's see the next one. They say both sweets have different colors. Okay, you see when they ask this kind of question, have different colors. If I never write this at the side just now, okay, by looking at this whole thing, it will be like very messy. I cannot see what is like, different colors. So now it's, you look at here, as long as the alphabet is different, of course, it means different color, right? Agree? So it means that for part 2, when they say probability of both different color, I will know that we are talking about these. We have a lot of different colors, right? So the trick is the lesser one is the one with the same color. Okay, so I'm going to do 1 whole minus probability of both same color. You understand? Because my both same color only have 3. 1, 2, and 3. So I take 1 whole minus these 3, it will be equivalent to the others. Okay? It's better than I go and take this plus this plus this plus this plus this. It becomes like it's more working. Understand? So both same color. So let's go and later we can work out this one. So now you can work out for both probability of both same colors. So we know that this one will be equals to same color one is 00, right? So just now we already do this one. So I know it's 5 out of 33. I'm going to plus, now is find PP. So my PP is half times 5 over 11. So half times 5 out of 11 plus my rate is 0. 1 over 12 times 0 is just 0. So it's just plus 0. Okay, so then of course I can work it out. So I have half times 5 over 11. And then after that plus this 5 out of 33. No need to plus 0, meaningless. So it's 25 out of 66. This is not the final answer, because I'm supposed to take 1 whole minus this. So therefore, probability of both different color equals to 1 whole minus 25 over 66. So 1 minus answer will be 41 over 66. And that's my answer. Okay? Okay, so now let's take a look. Now they say the first sweet is red and the second is purple. So with this, you can see red, purple. So I want to find RP, right? So where is RP? RP. So RP is only this one. First is red, second is purple. Okay? So it will be here and here. So take note of the English. If they say one sweet is red and one sweet is purple, then you got to take note that I also can say it is red purple and purple red. Then I will have 2 branch that I need to include. But this means that this only say first sweet is red, second is purple. So I only have one outcome, which is first sweet is red, second is purple. So this one, part 3, I will state probability of first red, second purple will be equals to red, purple, right? So it's 1 out of 12 times 6 out of 11. 1 out of 12 times 6 out of 11. Okay, so it will be 1 out of 12 multiplied by 6 out of 11. And we get 1 out of 22. Okay. Lastly, they say find the probability that the second sweet is orange. Second sweet, So now with this, it's easier to see. You only need to look at the second alphabet. Go and find those which is the second sweet is orange. So we have this, we have this, and we have this. So we have 3 possibility, correct? 3, Second sweet is orange. So this one only 3, so I can do it separately. So, okay, let me just continue here, which So if the question say red and purple, then there will be 2 solutions. Yes, correct. Okay, Minecraft, if they say red and purple means that I will have to include this one. So that means it will be half times 1 over 11 plus 1 out of 12 times 6 out of 11. Understand? If they say 1 purple and 1 red. Now it's first red, second purple, so only 1 possibility. So now I'm going to squeeze in here IV. Okay, IV say second sweet is orange. Just now we already show. So probability of second is orange. Okay. So let's take a look. So this one is the first one, right? So 5 out of 12 plus 4 out of 11, which I don't need to rewrite already because in front just now I already have a 5 out of 33. So I'm just going to take 5 out of 33 plus, this one is a second one, which I have to take half times 5 over 11. So it's half times 5 out of 11. And the last one is this one, which is 1 over 12 times 5 out of 11. So leave to the calculator, of course. So 5 over 33, okay, plus half times 5 out of 11 plus 1 out of 12 times 5 out of 11. And we get 5 out of 12. Ta-da! Okay. So far okay? So actually tree diagram is not that tough lah. So then, hi Miss got teach complex number other days. No, I'm not teaching complex number. Complex number is not under Sec 1 to Sec 5 O-level syllabus. Complex number is higher level. Okay. So let's see. So another thing you need to take note. Okay, they say that it has 12 sweets, right? Okay, and they say they take one after another. So this is saying that when I take one sweet, I don't put it back. That's why you can see that this one, the total was 12. When I take one, the second time when I take the second sweet, the total will change. No problem. Okay, so if this question change and say that, okay, they take and then there's replacement. It means I take one sweet, I will put back one sweet. Then the total will still remain as 12. Okay, so you got to take note of this key thing, whether is there any replacement. Okay, so let's come back to look at the last question, which is a tough one. So they say, okay, now Ben going to take the third sweet. Okay, going to take the third sweet. They say, find the probability that the third sweet is red. Then you say, huh? Wow. Thinking, then you may think that, wow, I have to draw a third sweet. Like I have to draw a third sweet column and then branch. But you don't have to do that. You don't have to do it for all the branch. Why? Because remember, we only have one red. Okay, so if you want to take the third sweet and that third sweet is a red, okay, let's take a look. I don't have to do the last branch. Why? Because I already take out one red, and there's no possibility that after I take out one red, I still have the third sweet to be red. You understand? So I can ignore the whole part of this part. Okay, I don't have to do for this part. Understand? Not only that, okay, then after that, you see, my second sweet when I take the red, okay, because I only have one red, right? So if my second sweet I already take the red, same thing, I have no more red, and so it's impossible to get a third sweet red. Got it? So in other words, I only need to focus on these, and this. The rest will not have the possibility of third sweet is red. Okay? So that means I only need to do branching for these 4. Understand? So I'm going to just put here the third suite is red. So how are you going to do it? 姐姐, is this ICGHE? No, this is O-level syllabus. Singapore Maths. Okay, so let's see. So this is OO, right? So if the third suite is red, so it's OOR, agree? So if it's OOR, okay, just do this. I just need to come out, say, okay, my red, it will be, because I never take red at all, so it will be 1 out of how much? See, I already took out 2 suites. So my total is 12 minus 2. So it's actually 1 out of 10, agree? I just need to branch out 1 out of 10. So it means to get OOR, it will be 5 out of 12. It will be 5 out of 12 times 4 out of 11 times 1 out of 10 to get OOR. Understand? And let's come to this one. Same thing. Okay? To get OPR, another 1 over 10. In fact, actually, it's all 1 out of 10. It's all 1 over 10. This one also same thing. POR. POR will be this, times this, then times 1 out of 10 again. Okay? This one also. PPR. It will be half times 5 over 11 times 1 out of 10. So actually, all of them is 1 out of 10. So, over here, the probability of third suite red is only equals to probability of OOR plus probability of OPR plus probability of POR plus probability of PPR. Okay, so only 4 possibility. Okay, only 4. So we will just do all the fraction. So the OOR is here. It will be 512 plus 4, 512 times 411 times 110. So it will be 512 times 4 over 11 times 110. That is for OOR. Okay, now go OPR. OPR. So OPR is this one. So it's OPR. So it's 5 out of 12 times 6 out of 11 times 1 out of 10. Okay. Next, POR. So where is POR? POR is this one. Correct. So it's half times 5 over 11 times 1 out of 10. So it's half times 5 out of 11 times 1 out of 10. Okay. And the last one is PPR. So PPR is here, half times 5 out of 11 times 1 out of 10. So it will be plus half times 5 out of 11 times 1 out of 10. Okay, so of course you press calculator and you will get the answer 1 out of 12. Done. Okay? So this kind of question, so of course student may ask me, what if the question asks, Ben take the third suite and find the probability that the third suite is like purple or orange. In that case, I have a lot of possibility. So usually when they come out this kind of question, usually it's for, it's for this kind of whereby the rates is only 1. So whereby you already ignore the whole main branch, whereby you already lessen down. Okay, it's not possible that they will go and ask you to go and do everything. So many possibility. Okay, so all good. Can understand the part C whereby I take the third suite is red. Anyone need me to further explain? Wait, how do you get 1 out of 10? Okay, see here. How do I get 1 out of 10? Because our first suite taken out, my total left 11, correct? So I take the second suite. Now my total left 10 suites. 12 minus 2, which is 10. So I have 10 possibility, correct? And my rate was 1. Because take orange, I never touch my rate, so I still have 1 rate inside the bag. So the possibility of getting the third rate is 1 out of the total 10. 1 out of 10. Okay? and it's all the same. Because take 2 sweets already, all the total left 10, and all I have only 1 red. This one take 2 sweet already, so total left 10, and then again the red is 1 only. So this one also the same thing. That's why all 4 of them, the third sweet, the possibility is all 1 out of 10, 1 out of 10, 1 out of 10, 1 out of 10. Okay? So that's how we get our part C. All good? Can I move on? So tree diagram is not that scary after all, right? Okay, let's move on. I think someone asked about tree diagram. I don't even know whether the student is here today or not. I think on Sunday or one of the live, some students request for tree diagram. Okay? Okay, thanks, Minecraft. Okay, so we have a last question on probability. Okay, so this one, maybe a lot of students will be very confusing. They think, there's no number in this diagram. How to find the probability? Thanks for the rows. Okay, so they were wondering how to do this question. So let's take a look. First, they mentioned that it is a square. It means that all 4 sides are equal. Okay. Next, they say PQR are midpoint. Okay, are midpoint. So it's important that you know that they are midpoint. So you know that here and here it is equal. Here and here it is equal. Here and here is equal. No, fraction. This one no need to use angle. This one use fraction. Okay, so with this, I'm going to draw some line. Then maybe you can visualize better. Wait, I take my pencil. So let's see. Let's take a look at the first question first. They say, okay, a point now is selected at random in the square. So they ask you, calculate the probability that it will lie in the triangle APQ. APQ. So what you need to do is, in this diagram, you're going to cut this into this APQ. How many APQ can I have? I'm going to draw this dotted line. Yes, well done. Split them into triangle. Good. So I'm going to split them. So, but this part, I cannot cut, because if I cut, then this looks funny. So how many of the small triangle do I have? It's easy. Look at this part. Okay, I'm going to draw this one like that. Look at half of the square. How many of that triangle I have? 1, 2, 3, 4. Wow, so many rows. 1, 2, 3, 4. 4 small triangle. Of course, naturally, this side will be 4 triangle. I don't have to cut it. So total, I have 8 small triangle. Understand? So in this case, I will say that the probability that it is in triangle APQ, it will be 1 out of 8. Done. What is it? The answer is, wait, let me see. Lies in the triangle APQ. 1, 2, 3, 4, 5, 6, 7, 8. What? I think this one, the answer is wrong. It's not 1 out of 36. It's 1 out of 8. Wait. Next. Find the calculate the probability that it will lie in a triangle BCR. Okay, BCR. Okay, so now you have to so-called remove all the small triangle. How many this kind of triangle can I form in this square? Okay, how many BCR can I find in this square? Yes, Minecraft, well done. Okay, 4, we have 4, so it's actually 1 out of 4. Okay, 1 out of 4, well done. So you see, I never do any angles, and I don't do any, I don't need any numbers. The crucial thing is you know that it's a square, and they say it's midpoint. So we can cut them into equal parts. Okay? Let's move on. So now they say 2 points are selected at random in the square. They ask, calculate the probability that both points lie in the unshaded region. Okay, unshaded region. Okay, so now how are we going to find unshaded region? So the best way is, I'm going to cut. You see, do you agree that this is 1 out of 8, right? So I'm going to find the shaded. So the shaded, unshaded, I'm going to take 1 whole minus 1 out of 8 minus 1 quarter. And then you become unshaded already, agree now? So just take 1 whole minus 1 out of 8 minus 1 out of 4. So my unshaded is 5 out of 8. Understand? So this is unshaded. All agree? All agree that my unshaded is 5 out of 8. So I took the 1 whole minus 1 out of 8, shaded small one, and the shaded big triangle is 1 out of 4. So I get 5 out of 8. So probability of 2 points in unshaded. Will be equals, the first point unshaded is 5 out of 8. Okay, this is area. So this is different from just now the sweep. Remember just now the sweep, when we take out one sweep, our total need to minus 1, so it becomes 11. So some student common mistake is, they say, okay, I'm going to take the 1 point, the first point is 5 out of 8. Then they say, okay, my denominator also need to change to 7. No. Take note, this is area. You see, it's like when I put one dot, okay, from this square, my square is still there. You understand? It's like a target board. My target board is still there. The area is still there. So in this situation, you do not need to minus 1 on the denominator. So it is still times 5 out of 8. Because it's two things happen at the same time, so it's 5 out of 8 times 5 out of 8, correct? So it will be 25 out of 64. Done. Okay, now next. They say, given that the area of the unshaded region is 90 cm square, find the parameter of the square. Okay, easy. Unshaded region is 90 cm square. And we know 5 out of 8 is 90 cm square. So you just know that 5 out of 8 of square equals to 90. So let's find 8 out of 8, which is the full square. All I need to do is just 90 divided by 5 times 8. So 90 divided by 5, then times 8, and we have 144 cm square. This is the area of the square. So to find the length of the square, of course, we just square root 144, and we know that it will be 12 cm. So now we know this is 12 cm, 12 cm. And they want to know the parameter. So easy, parameter of the square is just 12 times 4. So it's 48 cm. Done. Okay? Can? All good? If it's all good, we can go to prime factorization already. Can okay, let's move on. Prime factorization. So just now that probability tree diagram sometimes is taught in Sec 3, sometimes is taught in Sec 4. So now I'm going to do prime factorization. This is a Sec 1 topic. So I have students, I'm not so sure whether Cheryl is here. Cheryl is the one who requests for Sec 1 topics. Not so sure whether she made it for today. I think she said she got CCA. Okay. So anyway, this prime factorization is a Sec 1. For those higher level one, you can take it as it's a recap because O level will definitely test prime factorization. So my first few questions is very basic. We're going to do just the normal prime factorization, which is the ladder. Okay. They say find the HCF of each of the following set of numbers. Okay, I want to do my ladder. Okay, some school do this one. I'm going to show you how some school teach, but I don't like to use that one. Some school do the branching. Like divide by 2, I get 2 and 63. Then this one split, or this one don't need to split. They split. So it become like a spider web like that, you know. So I don't like to use that because it take up a lot of space. So I use my ladder. Okay, but both works. So what I do is, I only love tree diagram, but I hate the ladder. The ladder is fun, what? Somehow you can use calculator. Correct? So let's do the prime factorization for both number. Okay? Just to let you know, some school also do the ladder for HCF 2 numbers. So they do this. Sometimes they do this. They do both numbers together and then then they go and find the HCF. Again, I don't use that method. I just break my numbers into product of the prime factors. So let's do our 126 ladder prime factorization. Make sure the numbers that you divide on the left hand side are prime numbers. Like for example, you see this one. Sometimes you can see that, hey, I can divide by 6. Oh, happily divide by 6. No, you're not allowed to divide by 6. You still have to divide by 2, then divide by 3. Because you can only divide by prime numbers. Okay? So I divide by 2 first. Of course, I use calculator. So 126 divided by 2, I get 63. Wait, shift. Okay, so I get 63. Then I'm going to divide by 3 again, I get 21. Okay, and then I'm going to divide by 3, I get 7. Then I'm going to divide by 7, I get 1. Okay, so I know my 126 is equals to 2 times 3 to the power of 2 times 7. But for me, I'm very careful and I always check. Make sure that you go and key this one and make sure that it is 2 times 3 to the power of 2 times 7. Make sure when you press equal is 126. Because sometimes we may accidentally divide wrongly and then after that this one wrong, then the whole question wrong already. So I always do a double check to make sure that I did my prime factorization correct. Understand? So we're going to do for 5, 6, 7. So I'm going to do 5, 6, 7 as well. So 5, 6, 7, let's say definitely cannot divide by 5, 6, 7, let's say divide by 7. So if I divide by 7, I get 81. You see, I can divide by 9, but I cannot divide by 9 because 9 is not a prime number. So let's divide it by 3. So I get 27. Divide by 3 again, I get 9. Divide by 3 again, I get 3. Divide by 3 again, I get 1. So my 5, 6, 7 equals to, kids take note. Kids take note. You see, you only have 3, base 3 and 7. You don't have any 2, right? You don't have any 2. But over here, you can see that here got base 2. So please don't put here 3 to the power of something. If it doesn't have base 2, please put a 1 there to occupy the space there. Understand? Then I'm going to put the 3 to the power of 1, 2, 3, 4. 3 to the power of 4 here. And then after that, this one times 7. Again, let's check whether we got it correct. So it will be 3 to the power of 4 times 7. And you get 5, 6, 7. Understand? So now we have done our prime factorization. Okay, we have done our prime factorization. So now we're going to do our HCF. So what is the HCF? HCF is take the lowest from each column. Lowest from each column. So looking at the first column, 2 and 1, of course 1 is the lowest. 3 to the power of 2 and 3 to the power of 4, the lowest is 3 to the power of 2. 7 and 7, there's no lowest, there's no highest. Understand? So it will be just take 7. So this is my HCF. Then check whether they want it to be in index in prime factorization, in index notation or not. If you don't want, then you have to give in terms of number. So it will be 9 times 7. So it will be 9 times 7, that will give me 63. Understand? Wait, Mr. G 有人来按门。Okay, sorry, I ordered something. Then got people at the door. Okay, come, let's continue. So this is how I do my HCF, understand? I feel that this is a better way because with the same way of arrangement, I can do my LCM. Because if this question asks for LCM, I just need to take the highest from each column. So remember, HCF is take the lowest from each column. So student asked me, H is highest. This is Singapore Math, Singapore Math Sec 1. So you see, they say highest. Why is it you take the lowest? I take the lowest is because it is factor. Factor and multiple. Factor is smaller than multiple. Understand? Factor is smaller than multiple. That's why I'm taking the lowest from each column. Okay, so now next. Now we have 3 numbers. Okay, we have 3 numbers. So we're going to find the HCF of these 3 numbers. We're going to do the same thing. Do the prime factorization for all 3 numbers. So it will be 30 divided by 2, 15. 15 divided by 3, 5. Divided by 5, 1. 75. No problem. 75 divided by 5. Let's see. I don't want to test my mental sum, so I'm going to press calculator. 15 divided by 3, 5. Divided by 5, 1. 225. Divided by 5. 45. Divide by 5, 9. Divide by 3, 3. Divide by 3, 1. So let's list down. So my 30 is 2 times 3 times 5. My 75, no 2, you see, there's no 2, so please, I put wrongly, it's not multiply, put equal. So put equal 1 times 3 times 5 to the power of 2. Okay, 2 to 5. Is there any base 2? Also don't have. Put 1. 3 to the power of 2 and 5 to the power of 2. And let's double check that we did our prime factorization correct. So 2 times 3 times 5, 30. Correct. 1 times 3 times 25. Correct. And 2 to 5 is 1 times 9 times 25. Also correct. So let's take the HCF. Remember, HCF factor take the lowest from each column. So the first column, lowest is of course 1. 3 and 3, 2, lowest of course is 3. 5 and 5, 2, lowest is 5. And answer is 15. Yes, Raphael, good. Okay, so HCF is 15. So this is how I do my HCF. Okay, let's move on. I think the next question is about LCM. So we're going to do the same thing, but this time round, LCM is takes the highest from each column. So let's do our ladder. So 56 divided by 2, 28, divided by 2, 14, divided by 2, 7, divided by 7, 1. 1, 2, 6. I play cheat, Just now 1, 2, 6 we got do, right? So I'm going to just copy, Okay. So divided by 2, 63, divided by 3, 21, divided by 3, 7, divided by 7, and 1. So let's list down. So 56, we have 2 to the power of 3 times 7. Our 126 is 2 times, you see, I didn't write my 3, right? But I have 7 here, so I put 7 here first. And this one, I will have to put 3 to the power of 2. Then this one, I will put 1. Okay, it's not necessary must be 2, 3, 7, Okay, because I already write 2 and 7 at the first row, so the second row also must follow 2, 7. Then after that, the 3 just put behind, So now, LCM take the highest from each column. Okay, so the highest is 2 to the power of 3. The highest is 7. The highest is 3 to the power of 2. So press calculator, you will know that your LCM is 8 times 7 times 9, which is 504. Done. Okay. So we're going to do the same for this one, LCM. Again, do the ladder. So again, my 126, I already did here, right? So I'm not going to do, I just copy here. 126 is equals to 2 times 3, 2 times 7. So I'm going to do ladder for 168. So I'm going to divide by 284. Divide by 2, 42. Divide by 2, 21. Divide by 3, 7. Divide by 7 and 1. Yeah, 168. 2 to the power 1, 2, 3. 3 to the power of 1 and 7. My 756 equals to, divide by 2, press calculator. 378. Divide by 2, 189. 189 divided by what? 3, I think. Yeah, divide by 3, 63. Divide by 3, 21. Divide by 3, 7. Divide by 7, 1. So this will be 2 to the power of 1, 2. 3 to the power of 3, 7. Again, let's double check. I only need to check for 168, 126. I only need to check 168 and 1756. So it's 8 times 21. Yes, 168. Okay. This one will be 4 times 27 times 7. Yes, 756. So now I confirm that my prime factorization is correct. Let's do our LCM. So just to make sure that everyone is listening, LCM is take the lowest or highest from each column. My LCM, should I take the lowest or take the highest from each column? Well done. Okay, take the highest. So 2, 1, 2, 3 and 2, 2, we will take 2, 3. 3, 2, 3 and 3, 3, we will take 3, 3. 7, no high, no low, so we just take 7. Okay, so in terms of number, it will be 8 times 27 times 7, so it's 1512. Well done. Okay, so that's how we find LCM. Okay, so that's how we find HCF and LCM. Okay, that's the most simplest one. Okay, so now let's do this. So this, use prime factorization, find the square root and find the cube root. Of course, students say, hey, I can press calculator square root 1296 one. I can also press calculator cube root one. But the question asks for use prime factorization. So of course, you cannot just press the calculator. Calculator can only help you to check. Okay. So the bad news is I have to do ladder for my 1296. Okay. You imagine if I'm doing the branching, I tell you, I don't like. The branching occupied a big space already. So I like to use ladder because by looking at the ladder, I only need to look at this column to find out what are my factors. If I'm going to use the branching, my numbers is everywhere. Okay, at least how I feel. So let's do the ladder. 1, 2, 9, 6. Yes, well done for Minecraft. So 1296 divided by 2. I press calculator. 648. Divide by 2. 324. Divide by 2. 162. Divide by 2. 81. Divide by 3. 27. Divide by 3. 9. Divide by 3. 3. Divide by 3. 1. So my 1296 is equals to 1, 2, 3, 4, 2 to the power of 4, 1, 2, 3, 4, 3 to the power of 4. Again, check. 2 to the power of 4 times 3 to the power of 4. Yes, okay? See, okay, a lot of students, after writing this, they don't know how to present. So you must know 1296 in terms of prime factorization is this. They want to square root 1296. It means that I want to square root 2, 4 and 3, 4. So when you square root, actually is the power divided by 2. So what you need to do is just take the 4 divided by 2. The 4 divided by 2. That means the power must divide by 2 when you're doing square root. So it becomes 2 to the power of 2 times 3 to the power of 2, which is 4 times 9, which is 36. So we also must be smart to go and press square root 1296. We must get 36. Understand? Yes, correct. Okay, so this is how you do square root using prime factorization. Okay? So it's actually the same concept for cube root. The only difference is the power must divide by what? Anyone can help me over here? So while you all type in the chat, I'm going to just do the ladder for this one. Okay, for square root is divided by 2 for the power. For cube root is divided by what? Okay, type in the chat. Yes, divide by 3. Well done. Okay. So you see 1728. So let's just double check. 2 to the power of 6 times 3 to the power of 3. Yeah, 1728. Okay. So when we want to do cube root 1728, you just do 2, 6 divided by 3, 3 divided by 3. So we have 2 to the power of 2 times 3 to the power of 1. So which is 4 times 3, which is 12. But we also must be smart to check cube root 1728, 12. And we are done. Okay. So, before we go to the next question, okay, do you agree that, okay, I'm going to state here, this is called a, usually just 1 or 2 marks only, okay, 2 marks lah. Okay, let's take a look. But I can tell you this kind of question, okay, it is not that, this is not a common question that they come out. The common question that they come out is the one that I'm going to talk in a while. But this tells you that a perfect square, the power is multiple of 2. When it's a perfect cube, the power is multiple of 3. So you look at this. So we know that this is called a perfect square. Perfect square means a number that can be square rooted. Sometimes they call it square number. It means the same thing. So same likewise for this one. Okay, the power is multiple of 3. So we can say that this is a perfect cube. Or they call it a cube number. It's the same thing. Okay, so with this, the concept, we're going to do the next question. Okay, before I do this question, of course, I have to do my prime factorization for 4a. So I'm going to do just the ladder. So my 360 is 2 to the power of 3 times 3 to the power of 2 times 5. So let's just double check. 8 times 9 times 5. Okay, 360. So 4a very straightforward. I'm not going to explain about 4a. But now it's, they say, okay, find the small, this is a common question that they always ask. Common question they will ask. Find the smallest positive integer n such that 360n is a perfect square. So they're going to use 360, right? So I'm going to list down my 360 prime factorization, which is 2, 3, 5, 2, and 7, 2. Is it? No, this one is wrong. 2, 3, 5, 2. This is not correct, Wait. 2, 3. Okay, Sam, take note, the answer for this one is wrong. So this one, you should go and follow this one. Okay, so I'm going to list down. So this one wrong already. I have to copy 2, 3, 3, 2, and 5. Correct, right? 2, 3, 3, 2, and 5. Okay, confirm. Okay, so now they said 360 and is a perfect square. So remember what is a property? That it must be a square. My power must be multiple of 2. Agree? So time n means that you need to upgrade. You need to upgrade. So upgrade the power to the next multiple of 2. So this 2, 3, I have to upgrade to it to become 2 to the power of 4. This 3, 2 is already perfect square, so I just leave it alone. This 5, 1 is not. I have to change it to 5 to the power of 2. So with this, by comparing, you will know that 2, 3 to become 2, 4, I need 1, 2. 3, 2 to 3, 2, no change. 5, 1 to 5, 2, I need 1, 5. So the n we are talking about is 10. Okay, Minecraft, well done. Okay, so this is for B part 1. Perfect square. Okay, so this is for perfect square. I think behind I got perfect cube. Do I have perfect cube? Let me see. If don't have, then I will do... Okay, behind got perfect cube. Then I don't need to do another scenario. Okay, so next. Okay, perfect square always come out. So student, of course, most of the time they will know lah. Now next thing is multiple of 16. So they don't know how to do multiple of 16. First of all, I need to know my prime factorization of 16. Okay, so my 16 is 2 to the power of 4. Okay, and then I'm going to, same thing, I'm going to put 360n. Okay, my 360, I will list down my 360 first, which is 2, 3, 3, 2, and 5. So this is 360, and then this is n. So the thing is, what is my n? So remember this, what is multiple of 16? Multiple of 16 means 16 times 1, 16 times 2, 16 times 3, 16 times infinity. As long as it's multiple of 16, 16 times something means it's multiple of 16. So what does it mean? It means that for a multiple of 16, you must have all the prime factors inside the multiple. So you look at your 16, this one. So that means this is the minimum that you must have inside here. You understand? This is the minimum you must have. You can have more, but you cannot have less. You can have more, but you cannot have less. So let's take a look. Analyze this 360. My 360 got 2 to the power of 3. Not enough because I need minimum 2 to the power of 4. So in order to have it to be 2 to the power of 4, my n need to have a 2. So that 2 to the power of 3 times 2 will give me 2 to the power of 4. So I need a 2 in my n. Okay? I already fulfilled the minimum 2 to the power of 4. When I have the 3, 2 or 5, it doesn't matter. Because remember I said you can have more, but you cannot have less. So you don't need to bother about the 3, 2 and 5. I already fulfilled that I have 2 to the power of 4. So in other words, your n is simply just 2. All good. Can understand the multiple? Can I proceed to the next, or do you need me to explain again? Okay, let's move on. Let me see what's the next one. Okay, Minecraft, thank you. Can you explain part 2 again? Wait, Okay, no problem. Okay, so this is they want me to find the n which is so that my 360n is a multiple of 16. So first I need to know my 16 prime factorization. So 16 prime factorization is 2 to the power of 4. Understand? 16 is 2 to the power of 4. So when you want multiple of 16, you need minimum 2 to the power of 4 inside it. Okay? So I list down my 360 first. So my 360 is the one that I will break it up above. So I write it here. And then this portion is the n whereby you have to put in the additional in order to make this whole thing multiple of 16. So to be multiple of 16, you must have 2 to the power of 4 inside. So by analyzing this, you can see that I only have 2 to the power of 3. I didn't meet the minimum 2 to the power of 4. So in order to meet the minimum 2 to the power of 4, I need to times a 2 to make it 2 to the power of 4. So my n has to have a 2. Okay? Then this 3, 2, and 5 is extra. It doesn't matter because multiple of 16 can be 16 times anything. So in this case, it is 16 times this 45, which is multiple of 16. So the extra is fine. As long as it fulfills whereby I have the 2 to the power of 4, it means that it is multiple of 16 already. Okay, so in this case, I will see that, oh, so actually I only need my n to be a 2. You understand? All good. The 101Zn. Can you understand this part too? Good. Let's move on to the next. So over here is another multiple question. Okay. So they say, find the smallest integer p such that 42p is a multiple of the number blah blah blah. So the only difference is just now was multiple of 16. Then I need to do prime factorization. Now is they say multiple of this number. I don't have the number, but it's already break into the prime factorization for me. So it means that 2 times 3, 2 times 5, this is the minimum. Understand? This is the minimum I must have. Yes, I have to factorize my 42. So let's do our ladder for 42. Divide by 2, 21. Divide by 3, 7. Divide by 7, 1. So my 42p will be equals to 2 times 3 times 7. This is 42 times p. So let's analyze. Okay? Let's take a look at the minimum. I must have minimum 2 to the power of 1. Do I have 2 here? Yes, already have. So the first one already fulfilled. Okay, the 3 to the power of 2. I need to have minimum 3 to the power of 2. But my 42 only have 3 to the power of 1. So I have to make it 3 to the power of 2. In order to do that, I have to times a 3 here. So now 3 times 3 will be 3 to the power of 2. Now I meet the minimum 3 to the power of 2. Okay? Then my minimum got 5. But the bad news is my 42 doesn't have any 5. So it means that I have to include a 5 in my P. So now you look at the whole thing. Okay, you can see that now my, this is 42. You can see that my 42 times P now has 2 to 2 times 3 to the power of 2 times 5 and a times 7. The 7 is extra. It's fine. Understand? As long as it has all the minimum, it's okay. So now I know that my P will be 15. Okay? All good. Should be okay, Okay, let's move on to the next one. So this one say find the smallest integer k such that 1440 over k is a perfect square. Again, it's asking for perfect square. So the difference, what's the difference this and the previous one? Okay, perfect square. This is 360n. This is what I call upgrade because I want to make it a bigger number. That's called upgrade. Okay. Now this one is divide. So this is downgrade. Understand? I call it, I need to downgrade it. So let's do our prime factorization for 1440 first. So 1440 divided by 2, 720, I think. I don't want to trust my mental. Let's try. Divide by 2, 360 divided by 2, 180 divided by 2, 90 divided by 3, 30 divided by 3, 10 divided by 2, 5 divided by 5, 1. So my 1440 is equals to 2 to the power of 1, 2, 3, 4, 5. 3 I got 2 and only 1 5. Let's double confirm. So 2 to the power of 5 times 3 to the power of 2 times 5. 1440. So I know that my prime factorization is perfect. So now 1440 over k must be a perfect square. So it means that first you need to know that it is a perfect, you want it to be perfect square, plus you need it to be downgrade. So just now was, let's say 2, 3, we have to move up to 2, 4, for example, right? That's upgrade, become a bigger number. Now is you have to become a smaller number. So to become a smaller number, 2 to the power of 5, no, Minecraft 不对哦. Okay, I want to be a perfect square. So I need to downgrade my 2 to the power of 5. Because 2 to the power of 5 is not perfect square, I need to downgrade it to become 2 to the power of 4. Perfect square is the power must be multiple of 2. 3, 2 is already perfect square, so I don't have to touch it. My 5 is not a perfect square. I need to downgrade it to become 1 whole. Understand? Okay, so 2, 5 downgrade to the next perfect square is 2, 4. 3, 2 is already perfect square. We don't touch it. 5 is not a perfect square because it's 5 to the power of 1. 1 is not multiple of 2. So you have to downgrade it to 1 whole. So now by comparing, you can see that 2 to the power of 5 become 2 to the power of 4, you need a 2. 3 to the power of 2 to 3 to the power of no change. 5 to become 1, you need a 5. So in the end, answer is 10 again. Okay? So you need to know these few differences. You have perfect square, perfect cube, when is it upgrade, when is it downgrade, and then it's and the multiple one. You understand? So just now student asked me about the using prime factorization to do the square root and the cube root. That kind of question seldom will come up. But you must know that perfect square power is multiple of 2, but perfect cube is power must be multiple of 3. And that concept is used in this kind of question. They will always ask you what is the smallest, whatever it become a perfect square, perfect cube. Okay, then you need to know whether is it upgrade, is it downgrade. Okay, let's move on and see what is the next. This one, let's see anything special or not. Okay. Yeah, okay. This is nothing so special. Basically, this question it's a sum up of doing prime factorization, finding the HCF, LCM, finding the perfect. Just now we did only perfect square, but this question we have perfect cube. You see, perfect cube. So not only that, I also have multiple, I think. Next. So in this question 6, it is a recap of all the different concepts that we have just learned the 13 minutes, the past 30 minutes. So let's do, now the good news is 504 already do for me this one. I cancel a bit, I scared I got typo error. So 8 times 9, let's just check. 8 times 9 times 7, okay, it's 504. Okay, so now I'm going to do ladder for 108. Divide by 2, 54, divide by 2, 27, divide by 3, 9, divide by 3, 3, divide by 3, 1. So my 108 is 2 to the power of 2 times 3 to the power of 3. So 27 times 4, yes, 108. So this is for part A, very straightforward. Okay, so remember how to find our HCF. HCF, I need to list down the prime factorization of each number. So 108 is equals to 2 to the power of 2 times 3 to the power of 3. 504 is 2 to the power of 3 times 3 to the power of 2 times 7. This one don't have 7, please put 1. Okay, now I want to take HCF. So HCF is take the lowest or highest. Please type in the chat, just to make sure that everyone is listening. Who say hi? Who say highest? Okay, take note because it is factor. Factor. Factor is smaller than multiple. So we need to take the lowest. Okay. Okay, so Cocoa Tart, now you know HCF, don't look at the word highest. Factor is smaller than multiple, so take the lowest. So 2, 2 and 2, 3, you will take 2, 2. 3, 3 and 3, 2, you will take 3, 2. 1 and 7, you will take 1. No, Minecraft, the way you memorize, that's quite like memorizing without any logical explanation. It's like you memorize. Highest means lower, lowest means highest. It's like no logic. You understand? No logic, But over here, you know that they ask for factor, highest common factor. Factor is smaller than multiple. Then you link that is lowest. So it's more logical kind of a linking the memorizing. You understand? So every time you all need to memorize something, you need to find something that's logical, then you can link, then you can remember. Okay, by remembering highest is lower, lowest and higher, 不可以啊，不可以啊. That's quite kind of a not rational kind of a memorizing. Okay, so in the end, the HCF, it is 4 times 9, which is 36. Okay, math is not difficult. It's just that you need to practice, and always have to practice, practice, and practice. So you see, okay, now look at this one. The LCM of 504 and 108. Since it's the same set of number, I don't have to rewrite it. I can just use the same one and do my LCM. So I can just write, okay, my LCM equals to the highest. So you will take 2, 3, 3, 3, and 7. So it will be 2, 3, 3, 3, and 7. And the answer will be 8 times 27 times 7, and that will give us 1512. Done. All good. Okay, so now let's do this one. Perfect cube. Just now I did perfect square, perfect square. I haven't do a perfect cube. So 504p. So first we need to do the prime factorization for 504, but of course previously I already did it. Not did it. The question actually give it to us already. So 504 is 2 to the power of 3 times 3 to the power of 2 times 7. Okay. So 504p is a perfect cube. So put here, this is a cube, and you also know that this must be an upgrade because it's times p. So perfect cube, remember, perfect cube power must be multiple of 3. So I need to change it to the next power, the multiple of 3. So this 2 to the power of 3 is already perfect cube, so no need to change it. This one I have to change it to 3 to the power of 3. This one I need to change it to 7 to the power of 3. Okay. 2, 3 is already a perfect cube. I don't need to change. 3, 2 is not a perfect cube, so I need to change it to 3, 3. 7 becomes 7, 3. So in the end, if you by comparing, I don't need a 2. I need a 3. I need 2, 7. So it's 7 to the power of 2. So in the end, it is 49 times 3, which is 147. Okay, done. Can? Okay, now let's move on to the multiple. So because just now we already mentioned, right? So this multiple is just recap. So they say 108n is a multiple of 504. So my multiple of 504 is the minimum. So let's list down our 504 here, which is 2 is the one necessary. Oh, not necessary. The one is not necessary. I being kiasu, you know. I want to show that 2, 3, 2, 3. I don't need any base 2. Okay, but you can just put this one is fine. Okay, that is not necessary. Okay, 504 is 2 to the power of 3 times 3 to the power of 2 times 7. Because it is multiple of 504. Okay, so so multiple of 504 means that these is my minimum that I must have. Understand? My minimum that I must have. So now my 108n, so I have to list down what is my 108. Where's my 108? Okay, my 108 is 2 to the power of 2 times 3 to the power of 3. So this is 108, and this one will be n. So now let's analyze. I must have minimum 2 to the power of 3. So let's look at this line. Oops, I only have 2 to the power of 2. Means I need to multiply by a 2 to make it 2 to the power of 3. Okay? Then next, I must have 3 to the power of 2. But my 108 already 3 to the power of 3. So I don't need 3 already. I can, remember, I can have more, but I cannot have less. 3 to the power of 3 has 3 to the power of 2 already. It's more than enough. So I don't need a 3 in my n. Then my minimum, I need a 7. But my 108 has no 7. So it means that I need to have a 7 in my n. So therefore, my n is equals to 2 times 7, which is 14. Done. Okay, so today prime factorization, you have learned how to do ladder, you have learned how to do HCF, LCM, you have learned how to do all the perfect square, perfect cube, upgrade, downgrade, and multiple. Okay, now problem sum. Okay, actually this problem sum, I think my TikTok video post, I think I post before Okay. So let's take a look. So 3 traffic lights along a stretch of road will turn red at a fixed time interval. Okay, at 1 minute, 1 minute 10 seconds, 1 minute 18 seconds. There are occasions when all 3 traffic lights will turn red simultaneously. Cher, will you do Sec 2 math for next live? Sec 2 math for next live. Okay, anyway, I haven't decided my next topic, so okay, I can do Sec 2. Let me see. Sec 2 what topic? Okay, if you all think of a topic, want me to do for Sec 2 one, you can 点菜 here, 点菜. But again, it depends on me to decide whether I want to do it, okay? So you all can order the food here, order the food, which is the topic. Okay, then I will decide. Simultaneous equation, so easy. Minecraft. But it's fine. I will do simultaneous equation. Then I will do the more slightly chim one. Okay, so that it will benefit you when you do your Sec 3A math. Okay. Minecraft got 3 equations, man. Oh, I think I know what you mean. You mean something equals to something equals to something. Is it? Is that what you mean? Kokota. Can do congruent triangle for Sec 4 after the Sec 2 one. Got order already. Let me write down. Later I forget. So Minecraft 1 simultaneous. Okay. I write down the name. When I do the topic, then the student is not here. Okay. Congruent triangle. No, like usually only 2 equations to compare, but some questions got 3 equations. How is it possible got 3 equations? You mean like something like a 2x plus 5y equals to 3, let's say 2x plus 3y equals to 4x, something like that. Do you mean this? I am a full-time tutor. Full-time tuition, private tuition. I give math tuition. I'm not a MOE teacher. Sure about what day to Sunday lah, Minecraft. My life so far is my life so far is quite fixed. It's on every Wednesday 8 to 9:30 and every Sunday 5 to 6:30 p.m. Okay, every Wednesday 8 to 9:30 and Sunday 5 to 6:30. Okay, so Minecraft, do you mean this kind of question? I don't recall having three equations, because when you have two unknown, you only need two equations to do simultaneous, right? So how is it that there will be three equations? Unless you have the first two equations, then you give birth from one of the equations, then you have equation 3 lah. Then that's a different thing. But the original is still start from two equations. Okay? Because three equation means you're trying to tell me that you have three unknown to solve. But no, we don't learn three unknown for secondary school syllabus. Okay, so Minecraft, I see you on Sunday. I'm do simultaneous. Sunday I will do simultaneous. Come, let's come back to this question. Okay, I OT already and now 9:30 already. Okay, quickly do this question. So now 1 minute 10 seconds and 1 minute 18 seconds. I'm going to change them to second. Okay, so you will be talking about 60 seconds, 60 plus 10, 70 seconds, and talking about 60 plus 18, so it's 78 seconds. Okay. So those who are not following me, please remember to follow me, because when you follow me, when I do my live or when I post videos, you will get notification. Okay, so 60, 70, and 78. This is the 3 traffic light. Okay, so what I need to do is, when they ask you when will they flash together again, okay, when will they flash together again, it's trying to find the LCM, lowest common multiple. So how do you find the lowest common multiple is, remember just now what we did, we already learned how to do LCM, right? So that means I'm going to do ladder for 60, 70, and 78. So it will be 60 divided by 2, 30, divided by 2, 15, divided by 3, 5, divided by 5, 1. 70 will be divided by 2, 35, divided by 5, 7, divided by 7, 1. 78 divided by 2, should be 39, 39. Divide by 3, 1, 3, and divide by 13, 1. So my 60 will be 2 to the power of 2 times 3 times 5. Sure, can do circles on Sunday also. Circles and then properties of circle. You mean E-math circles, right? Not A-math circles, right? Fury 1002 circles. So it's E-math circles, Okay. Okay, so see here, 60 is here, so 70. Okay, good. So 70 equals to, so this coming Sunday I will do simultaneous and circle. Okay, I can do these 3 lah. Most likely I will just pick 2, 3 questions from each. It should be 2 questions, 2 questions, 2 questions lah. Okay, 2, 2, 2 lah. Do 6 questions. Can? Okay. This coming Sunday, which is on the 23rd of Jan, 5 p.m. to 6:30 p.m. Okay. This coming January, this coming Sunday, 5 to 6:30. See, I write down the name already. This Sunday, if I don't see these 3 names, next time you all order the food, I don't bother about you. I don't care. Okay. If you never turn up, next time you order, I don't care. I don't take into consideration. Okay, so 70 is 2 times, don't have 3, so it's times 1, times 5, times 7. So this one times 1. My 78 is 2 times 3, times 1, times 1, times 13. Times 1, times 1. So let's just double confirm that I do my prime factorization correct. 4 times 15, correct. This one is 2 times 5 times 7, also correct. 2 times 3 times 13, also correct. Okay, so with this, I can find my LCM. So my LCM is take the highest from each column. So it's 2, 2, 3, 5, 7, and 13. Okay, so it will be 4 times 3 times 5 times 7 times 13, which is 5460. Take note, this is second, because all this is second, correct? So initially they started to flash at 9:15. So I'm going to find 5460 seconds. So of course 5460 I'm going to divide by 60 to find out how many minutes. So it is equals to 91 minutes. And 91 minutes is actually 1 hour and 31 minutes. Okay, so that means they will flash together again at 1 hour 31 minutes later. So it's 9:15. So it's 9:15 a.m. plus 1 hour 31 minutes. That will give us 10:46 a.m. Done. Yes, 10:46 a.m. Well done. Okay, so that's for question 7. Understand? So whenever they ask you, oh, when will they flash together again? Just remember that this kind of question is to find the LCM. And all the basic skills that you have learned how to find LCM is do the ladder, put them into the column, take the highest from each column. Okay, move on to the last question for the night. Okay. This one is company pack these boxes of chocolate, this packet of juice, and these sandwiches into as many goodie bags as possible for their employees. So the number of boxes of are divided equally among all. So you see, you want to break them into smaller. So that means I need to know how many goodie bags I can put them into. So you're actually trying to find the HCF, highest common factor, because you need to split the chocolate and the juice and into the goodie bags. So I want to know how many goodie bags I need. Okay, I need to know how many goodie bags I need. So it's finding the HCF. So again, these three numbers, go and do the prime factorization. So 352, 572 as well as 1144. Okay, divide by 2. 176 divide by 2, 88. Divide by 2, 44, divide by 2, 22, divide by 2, 11, divide by 11, 1. 572 divide by 2, 286, divide by 2, 143, oh, this one divide by what? 11, and divide by 13, 1. 1144, divide by 2, 572. I'm going to play cheat. Do you see that this one divided by 2 is 572 already? So actually I don't have to write some more, because I just need to do 1144 is just 2 times all this. Agree? So my 352 is 2 to the power of 1, 2, 3, 4, 5 times 11. My 572 will be 1, 2, 2 to the power of 2 times 11 times 13. My 1144, because I'm going to use these 2 times all these, so that means it's 2 to the power of 3 times 11 and times 13. Okay, then let's double check. So 2 to the power of 5 is 32. 32 times 11, yes, 352. 4 times 11 times 13, yes, 572. Then 8 times 11 times 13, yes, 1144. And we're going to take the HCF, which is the lowest from each column. So HCF, take the lowest. I'm going to take 2, 2. 11 got no lower or higher, take 11. This one take 1. So it will be 4 times 11, which is 44. It means that I'm going to pack into 44 goodie bags. Okay. So this is for part A. Next they ask, okay, how many boxes of chocolate bags are in each goodie bag? So it means that this 1144 I will split into 44 bags. This 352 I will split into 44 bags. So simply just take 1144 divided by 44. This is the number of chocolate. 26 boxes of chocolate. Next is 352 divided by 44. So it will be 8 packet of juice. And the last one will be 572 divided by 44. 13. So it will be 13 sandwich. So 26, 8 and 13, yes. So this is how you do this kind of question. Can? Not bad. Today I only OT 10 minutes. Okay. So today we have learned probability, tree diagram and possibility diagram. And we have learned prime factorization. Basically, I cover the prime factorization kind of 90% of all the commonly asked questions. Okay.